Hello, everyone.
Hello, Daniel. Good morning.
Good morning, Nathan. Good morning, good afternoon, good evening to everybody joining us today. My name is Daniel Moyer. I'm a sales support trainer here at Briggs Stratton Energy Solutions. With me today is Nathan Heston. Hello, Nathan.
Hello.
Hi. And what we have today is we're going to be talking about battery energy storage and generator integration, right? How can a battery home energy storage system and a generator complement each other rather than compete with each other? So we're going to talk about who is Energy Solutions at Briggs and Stratton, market drivers, market growth, talk about the advantages and disadvantages of both battery storage and generators, how and why to combine the two. Talk a little bit about the old portable generators that people have sitting out in the garage, probably haven't started up in a while. And finally, we're going to look at some layouts. A couple of housekeeping items is that we don't have this course NABCEP accredited just yet. Next time you do attend this course, it should be NABCEP accredited. So we're not going to be able to issue any credits. However, stay tuned for an upcoming one that is accredited. If you have any questions during the talk, put the questions into the Q&A chat. It's the Q&A button either at the top or the bottom of your screen. And we'll go ahead and answer the questions live during the training. Nathan might type out the answer for you, or we'll save a little bit of time at the end. So welcome, everybody. Maybe somebody put into the Q&A, did you go to RE Plus last week? And if you did go to RE Plus in Las Vegas, what were you excited to see? What kind of new things were you looking at? I love to hear the stories. We had a great opportunity to be there. We did have a couple of our generators there. We had a 26K and a 12K generator. Before we get started, I want to be sure to really promote our new Briggs & Stratton Power Academy. It's an amazing online portal that has in-person courses where we'll actually bring one of our travel trailers out to your site. It has generators and energy storage systems in the back. We can do e-learning courses, Power Academy Live, and then live virtual courses like you're seeing today. Also check out our training calendar on simplifypower.com as well. So if anybody has taken these courses before, we're going to kind of get through some of this early stuff kind of quickly. I'm going to run pretty fast so we can get into the meat of the subject, which is how generators and energy storage combine. One thing to keep in mind is that it's one company. It's one solution you can count on. So Briggs & Stratton Energy Solutions has been around for a long time. Now that we're part of Simplify Power, we combine both generators and energy storage into one complete solution provider. So that's one tech support call. That's one manual. It's something that's been vetted and knows that they'll work together. So that's really exciting to have that. Also keep in mind that these generators and the batteries are assembled in America. And so we're really proud to be able to offer that as well. Again, Briggs & Stratton, the company has been around for a long time. We have a huge presence and we have a lot of capabilities. This allows us to really be there for you in the future. We know that we're not going to be, you know that we're not going to be disappearing in a few years. We're here to be here for the long run. Some of the market drivers is definitely home as a haven. We saw this come out of the pandemic. A lot of people are working from home. A lot of people are learning from home, and having reliable power on your home is important. Existing infrastructure needs to be upgraded. I know out here in California with Pacific Gas and Electric, they had a lot of fires being started by power lines swaying in the wind. And they do these public safety power shutoffs. Well, there's nothing safe about shutting millions of people's power off. Right now, PG&E is quick to start burying these lines, but really the infrastructure around our country isn't where it needs to be. And by having distributed, reliable assets on the consumer sides at your homeowners, at your business owner customers is really going to create a more resilient future. Climate-related
disasters. I would have to say that number 2 and 4 there, the existing infrastructure needs investment. It really couples with the fourth one down that you have, and that everything is electrifying. So the fact that we have so many more things coming online, like electric cars in California, contributes to PG&E's infrastructure not being quite what it should be. Now these existing power lines have to carry a lot more power because the demand for power is going up. And so even though we have aging infrastructure, we also have a rapid growth in demand for electrical power.
Yeah, great point, Nathan. And that's another brings me into this is that I'm always so proud and amazed by how so many of you installers out there don't do just solar and batteries and generators, but you also do so many other things to help electrify these homes. Put it in the chat. Are you doing heat pumps? Either mini splits or ducted systems? Are you doing heat pump water heaters? Are you doing EV chargers for your customers? So the idea that you're just going to come out and put solar panels and batteries on a house and run back to the van, I think is a thing in the past. And I'm really excited that so many of you out there are offering more than just that. You're offering a complete electrification of people's homes. One thing that's really been pushing the industry forward is the growth of clean industry, clean energy policies and solutions. Part of that is coming out of the IRA. It's 30% tax credit. And now you can take a 30% tax credit on just the energy storage alone. Historically, you would have to match both both the solar and the energy storage together to take the 30% tax credit. You can now just install just a battery, no solar maybe, take that 30% tax credit. You can't take it on the generator, but you could add a generator into the mix and then use the generator to charge up those batteries if you don't have solar or if it's cloudy out. So stay tuned for that. One thing to keep in mind is that there's a lot of people out there that already have solar that now want to add batteries to their systems. And that really plays into adding that 30% tax credit on the energy storage alone allows them to do that. People may have older systems, and you may need to think about what kind of systems you can AC couple to. Email us. We have a whole team of application engineers that can assist you in designing your systems and making sure we vet the systems to work correctly. Talked about it already. Backup power, utility bill savings. I just recently had an opportunity to do a co-hosted webinar with Josh Brum at Solagent about the future of solar sales in California under NEM 3.0. And if anybody hasn't been paying attention, NEM 3.0, which is the new net metering agreement in California, really makes it so that a photovoltaic system by itself is not a financially viable kind of payback unless you pair it with storage. So now that we can add these storage systems on the consumer side and not only provide backup, but also give them the opportunity to make a return on their investment is really crucial to making these things move forward. And I also think it's really crucial to how the grid is going to be in the future, that we have solar during the day. What happens at night? We can use our batteries to help power the grid at night. Off-grid has been something that generators have always played a role in. Generators in off-grid systems have always been there. Usually, why? Because of winter. Why would I oversize your solar system huge in the summer just to get you through the dead of winter? Normally, the way I always used to size it is let's give you a good system to get you through most of the year. When those long nights in winter and a big storm comes in and there's no sun to really charge up those batteries, we can run a generator, charge up the batteries, and then shut it off. Well, now there's an opportunity to make that happen on grid as well. And we're going to talk exactly about how to optimize generators for energy storage systems. So let's take a step back and just talk a little bit about the pros and cons of generators and pros and cons of energy storage. Why are generators amazing and have been so popular? One is they have unlimited fuel. Really, if you think about it, you have a natural gas pipeline coming to your house, and that's essentially an unlimited source of energy, unlimited source of fuel. And there's a lot of energy embedded in natural gas and propane that can be turned into power for your home. Maybe you got a 1,000-gallon propane tank in the backyard. That's not going to run dry anytime soon. So there's unlimited fuel. You really, in a lot of these generator systems, we've always done whole home backup. We usually do 100 or 200 amp transfer switch where we're backing up the entire home. I am going to talk a little bit about load shedding, where maybe we could undersize the generator a little bit using our load shedding devices to drop out loads if the consumption of your house loads exceeds the nameplate rating of the generator. But really, a lot of times we can back up your whole home. There's usually lower upfront costs. Now, notice I said upfront costs. We're going to find out what the long-term costs might look like. and you're not dependent on solar insolation. What I mean by solar insolation, and that's different than say nighttime or cloudy, is maybe you live in the redwoods like I do up here in Arcata, California. Maybe your house is covered by trees and there's no opportunity to put solar panels on the roof. So you're not dependent on that solar insolation. You don't need the sun to make a generator work. But again, nighttime and cloudy operations, maybe you do have solar, but it's cloudy out, it's a big storm, and you're not able to charge the batteries. What are some drawbacks of a generator? One is safety. Carbon monoxide poisoning was a huge potential problem, and I'm going to actually address that here in a couple slides and show you how far away you need to have these generators from openings in your house. Fuel costs, right? It costs money for that propane truck to drive out to your property. You are paying for that natural gas that's being consumed by the home. Maintenance is a big thing, and one thing that I've always noticed is a lot of generator dealers make a lot of guaranteed money on their maintenance contracts. They sign homeowners up for these packages and get them into long-term contracts where they'll come out and maintain the generators. That costs money. I do recognize that that is a source of income for generator dealers. So you may be able to sell a maintenance package, and I've seen people do this, and I know it happens, sell a maintenance package on solar systems, clean the panels, check for loose connections, make sure we retorque things. It's essential, but keep in mind, that's a lot less than, say, oil changes and air filters and valve adjustments. Installation location, a lot of generators have, like I mentioned, have to be a certain number of feet away from openings in the house. Maybe they have to be, because of homeowners association requirements, you can't install one. So it's definitely kind of isolating where you can install these generators. Frankly, I've also seen that come up a little bit in battery energy storage systems where inspectors and AHJs are being a little more tough on where you can install energy storage as well. Everybody knows a generator is noisy. It creates fumes. One thing also is gas lines. I can see that, if you got to place a generator on one side of the property, but the gas main or the propane tank is on the other side, that's a lot of black iron to run. You got to get the threader out. So running gas lines is no fun. Nobody wants to be underneath the house running gas lines. You don't have to do that with energy storage. What makes energy storage better? It's eco-friendly. It's potentially safer. And the reason I say potentially safer is that in the energy storage industry, there's a couple of different chemistries of batteries. And I'll get to a slide here in a second. We leverage lithium ferrophosphate, or LFP, lithium iron phosphate, a lot of people talk about. And that is inherently safer chemistry. A lot of people in the industry are moving that way, but we've been the first. And we're also leveraging a cylindrical cell. Save money on your monthly electrical bills, like I talk about in NEM 3.0 in California. You need this battery system to be cycling and helping to support the home's loads. A lot of people are getting put onto time of use rates as well. Well, we can use energy storage systems to work, right? A generator just kind of sits there. It just sits there waiting for an outage. And home energy storage system is able to be more interactive and be able to be dynamic daily. Talked about the 30% tax credit already. I think a lot of people don't realize is that how fast these energy storage systems transfer times are. Our inverter, which you see down there on the bottom right, our Simplify 6K inverter has an 8 millisecond transfer time, which means that you barely see the lights flicker. You don't have to reset all the clocks, and usually the internet doesn't reboot. The generator, with the break before make contacts, it's usually, and the generator has to warm up, it's usually about 30 seconds to 1 minute. So you're going to have to reset all the clocks. The internet's going to reset. Disadvantages, energy storage system, well, it costs more money up front. But when we start to look at the lifetime savings potentially of not having a maintenance package, of it being able to be more grid interactive, really the lifetime cost of an energy storage system is on parity with generators and potentially even better. Usually we're only going to back up critical loads with energy storage unless we're starting to do a whole home backup with load shedding. I'm a big proponent of that. Anytime I back up an entire home, they usually drain the battery and they're not necessarily paying attention, but it can be done. A lot of people don't like pulling critical loads, right? You got to pull loads out of your main panel and move it over to this sub panel, this critical load sub panel. Nobody likes doing that. The installers don't like having to do that. But so it's always something that you got to budget in to make sure you're not losing money on having to do that. Limited power and energy. We're going to get into that in a second. Power, as in it's not as many watts to start large loads, and energy is that there's not that unlimited source of fuel. So kind of way to help you wrap the head around energy and power is think of energy as in your batteries as the fuel tank, and how much energy right in the fuel tank is kind of equivalent to how much energy you have in batteries. Instead of gallons of propane, we're going to think of kilowatt hours in batteries. Power. Think of the inverter as the engine, right? The power is in watts. Our 6K inverter can surge. It can go up to 9K for 30 seconds and 12K for a couple hundred milliseconds to start up larger loads. But think of the inverter as the engine, right, of a generator. So that's kind of a nice way to help explain it to homeowners as well as installers. So kind of the little schematic here we're taking a look at. When you notice a generator, we normally would do whole home backup. In a grid up scenario, here's grid, flows right through your meter can, passes right through that transfer switch, backs up the whole house, powers the whole house. In a grid down situation, the transfer switch is going to recognize that the grid has gone down. It's going to then start up the generator, prove the generator is working, got a good, nice, clean hertz and voltage, and then we're going to go ahead and transfer and start backing up the entire home off of that 26K generator that you see down there at Power Protect. Energy storage systems, we usually have a kind of a little bit of different architecture. We still got grid, we still got a meter can, right? Because they still want to know how much power we're using. But now we have non-backed up loads here. Inside of the inverter, of our hybrid inverter, is a transfer switch. It's a microgrid interconnection device, but it's a transfer switch. So in a grid down situation, the inverter is going to recognize that grid has gone down. It's going to disconnect us from grid, so we don't want to be backfeeding the grid when the electrical lineman down the road who's trying to get the power back on in the neighborhood gets electrocuted. So we're going to isolate from the grid, and we're going to immediately, within 8 milliseconds, start backing up our critical load subpanel. We got a couple 4.98 batteries, and we're showing the app here. Quickly, let's just run through some of the products, and then we'll kind of get into more of the meat of the subject. Simplify Power, Briggs Stratton has been making the Phi and Amplify battery, which is on the far left there, for a long time. The Phi battery, which does not have closed loop communication capabilities, has been a perfect pairing for a lot of older systems like Schneider, Magnum, Victron, Morningstar. These batteries have been proven to work in we still make an inverter agnostic battery, and we've done a lot of systems where we use other people's inverters. We have integration guides on our website that tell you how to program those pieces of equipment, and I know a lot of historical, those systems have been with generators on them as well. We do make the Amplify version of that same 3.8 kilowatt hour battery with closed loop communications. So if you have a piece of equipment like a solar or like our inverter, you can then use the closed loop communications to get a more accurate state of charge, auto populate set points in the inverter, and potentially protect the battery during cold or hot temperatures. The communicating batteries are able to tell inverters that it's too cold or too hot. That doesn't mean that the non-communicating batteries are any less good or valuable. It's just if you don't have a piece of equipment that can't listen or talk to a communicating battery, don't necessarily leverage it. We have a Boss 6, Boss 12 cabinets that can house these batteries. But if you're looking, because they're not outdoor rated, but if you're looking for an outdoor rated battery, we have the Simplify 4.98 battery that you see on the left here. In the middle is our 6K inverter. And on the right is our Energy Track app. And one thing I noticed at RE Plus last week is that there's so much importance being put on software. And why? Is because that's how our customers, our homeowners, our business owners interact, and installers interact with these systems. Nobody goes back out to the Power Shack and looks at the screen on their Trace inverter anymore, or their battery monitors. They look at apps, and having an app that has privacy and your data housed here in the United States is important. Having it to be able to have functionality like remote reconfiguration and being able to have just something easy for the homeowner to use has been important. Again, the Phi non-communicating 24 or 48 volts. In the middle is the Amplify 3.8, 48 volts only with closed loop communication. And the battery, Simplify 4.98 battery on the right there. We can take one of these Boss 12 cabinets and put an inverter up top. We can either do a solar up to a 12K solar or put our inverter up top. Down bottom, we can put up to 6 batteries, and it makes it easy. Makes it really simple. There's bus bars and terminal blocks to really make this an easy install. Get your crew out to the next system doing the next job, and not sit there worrying about running conduit and the likes. Of course, you do have to run some conduit to your backed up panels. We do carry those UL listings, which a lot of jurisdictions are going to be looking for. Another thing in RE Plus that I was really excited to take a look at is some of the high voltage inverters offered by Solar. The Solar 30K and the Solar 60K. It's a 480 or a 208 three-phase inverter. Those new large commercial inverters need high voltage battery packs, and we offer that with our high voltage battery solutions. I'm not the expert in it. If you are interested in learning more about this, email me. My email is going to pop up at the end of this end of this talk, and we'll go ahead and look through some of the. We can help you look through some of your proposals and your quotes. As I mentioned before, we have a little bit of a wider temperature window than a lot of other battery competitors have. Why? Because our batteries can have built-in thermistors or thermocouples that can transmit their internal temperature, which may be different than ambient temperature, up to a piece of equipment like a solar, like a Briggs Stratton inverter, and adjust the charge voltage of that battery so that it doesn't damage the battery. We're not the only ones. In fact, all lithium-ion batteries can't be charged below freezing, or you'll damage the battery permanently, potentially. So what we're able to do is use a slower charge rate to use internal resistance in the battery to slowly warm up that battery. Something very unique. And we have other trainings where we spend the entire hour talking about this subject. So stay tuned for some of those upcoming trainings, and we'll get a little bit deeper into that subject. Warranty matters. Not only does the warranty matter, but the company behind the warranty matters. At RE Plus, there were so many new inverters, so many new battery companies. I could barely keep track anymore. But one thing I know is that they've only been around for a couple of years, and we haven't. We've been around a long time, and we're able to stand behind our new upgraded 15-year warranty. This is a warranty on the Amplify and Simplify batteries, the communicating batteries, 15 years. Unlimited cycles, 100% depth of discharge with no throughput warranty. So we don't have any of those if, this, then, or that kind of clauses in our warranty. And we're able to really offer that battery to be able to work, cycle it daily to help save money during time of use. Lithium iron phosphate is the chemistry we use. It's not just chemistry, though. As I was walking around that RE Plus show, I noticed a lot of our other competitors were using pouch cells and prismatic cells, which definitely don't have as long of a life and potentially can't contain any thermal runaway event the way a cylinder can. Think of a cylinder inherently has a lot more structure to it and safety to it. So Nathan, what was exciting about you at RE Plus, and what did you notice in regards to chemistry and form factor?
Well, in regards to chemistry and form factor, I think there's a lot of improvement that has been made in cells over the years, and they continuously get better and better. I got a chance to speak with our cell supplier and note some of the improvements that they've made in efficiency and helping to drive down cost. And I think that these improvements overall will certainly contribute to being able to get higher capacity battery systems into people's houses at more affordable prices. And I think that that's extremely exciting. As you mentioned, there were lots of new companies that were kind of coming to the market, and it reminds me a little bit of the boom of solar panels in the early 2000s, when you had so many companies coming in and offering strong warranties, etc. And then, some of those companies didn't survive. So there were a lot of interesting things happening. You mentioned Solar's 30K and 60K inverters, which were debuting at RE Plus this year, which was exciting. And you can use up to a 500-volt battery bank with those. I was excited to give a joint presentation with a trainer from Solar, Dylan Hillman, And so we're excited to bring those solutions to market as well for the C&I customers that are out there. That and innovations in solar panels as well. So there was a lot going on, and if you did make it to RE Plus and have comments, we'd love to see those in the Q&A. And I know people are eager to get into the content, so I'll let this go. I do want to mention that people are also interested in off-grid, and I know you're going to hit on it here, but that was noted earlier by, I believe, Joe. So thanks, Daniel.
Yeah, thank you, Nathan. And one of the things some of this does, is part of why we're talking about this with generators. And one of them is not just that capacity, but also the ability to charge a battery quickly and discharge it quickly. So when we're talking about integrating a generator into an energy storage system, we want to run the generator kind of at the highest load, at the most fuel efficient point at the generator, right? Which is usually around 70% load on the generator. A lot of times when you're running a generator, and even in those whole home backup systems, and we have histograms in our GC1031 controllers on our Briggs Stratton generators that show exactly what load and how many hours a generator's been running at. A lot of times they're running at 20 or 30% load. So the idea is that let's kind of make that generator work harder, but for a shorter amount of time. And one thing that if we're going to make that generator work harder, we have to make sure that we have somewhere for that power to go. And one thing that makes these generator systems work is that we can charge the batteries quickly. A C rate, right? A C rate is the rate at which you can charge or discharge a battery relative to its capacity. With the C/2 discharge rate, we can charge up a battery in 2 hours, shut the generator off, and then coast on the batteries. So again, some of this is, kind of sales pitchy stuff, but again, it's important to realize some of these specs matter when we're starting to talk about how to integrate a generator into an energy storage system.
Hey, Daniel.
Yeah.
Joe asked a question about why we use cylindrical as opposed to prismatic, which can offer better energy density. And if you don't mind, I'll take a second to answer that.
Yeah, thank you.
So Joe, one of the reasons why we use cylindrical cells is that the cells themselves are rigid and basically prevent thermal expansion and contraction. And one of the things about prismatic cells, though, you can pack a little bit more energy into those cells, and you have less wasted space with a prismatic cell. We don't often, for home battery backup, care that much about energy density, right? We're not that concerned with making tiny products that you might be if you were trying to fit it in, a mobile application. Additionally, the cylindrical cells offer a much longer longevity due to the fact that you're using hermetically sealed cells that are encased in a steel casing as opposed to that plastic. So that the swelling and contracting with the heating and cooling of the prismatic cells would give us a little bit less cycle life. And so to get that highest percentage, the longest cycle life, we use premium cylindrical cells. That doesn't mean there isn't a place for prismatic. There is a place, especially if you're trying to go to lower cost batteries. But what we're really looking for is the greatest number of cycles for our customers, because one of the big things with battery backup is the cost of installation, right? And so we're spending that money on the installation. We want to have a long-lasting battery that we can warranty for 15 years and expect even longer out of it. Then we're going to use the highest end cells that we can get. And that's why we use cylindrical as opposed to prismatic. So again, there's a market for prismatic, and a lot of our competitors choose to use prismatic, which saves money on cost. It's a lower cost battery, but they're not going to get quite as many cycles out of the batteries that we can. So hopefully that answered it. And again, there's an argument to be made for both.
Thank you, Nathan. Keep in mind is that you can scale these batteries up, right? You can scale them, and we chose smaller building blocks like 3.8 or 5 kilowatt hour building blocks so that you can scale them up just under what the, say, AHJ's maximum requirement is for a certain kilowatt hour threshold for one installation location. For example, in Los Angeles, I believe it's 20 kilowatt hours in one location. The ability to expand, what that means is that we can come back out to an existing site, to a homeowner, sell them a smaller bank, and then in the future add more batteries to the system. We make air-cooled generators. What you're seeing here are gas, either natural gas or propane generators. We have them all the way down from the Power Protect 10. Power Protect 12, I think, is a great pairing for our inverter, or I'll tell you why in a minute. Power Protect 17, the 20, and the 26. The ones on the far left are upright ones, which allow you to kind of put them into a smaller footprint, kind of get them into a smaller spot that you otherwise wouldn't be able to get them into. We also have a full line of liquid cooled generators. I am definitely not the expert on those commercial liquid cooled generators. If you are, let us know and I'll connect you up with that team, and we can look forward to having that discussion. Transfer switches are also available as well. So again, when we're going to be pairing a generator with the energy storage system, make sure that the generator you're going to place is in the right location, right? It needs to be 5 feet away from any openings in the building, whether it's a soffit vent, a dryer vent, a window, a door, so that you're not going to have that risk of the fumes kind of coming into that, and 18 inches from a combustible structure. Definitely what makes it these engines and generators, what generators work is the engine. And we have a historical history of making high quality engines from Briggs & Stratton, and the Vanguard engine is no different. One thing I want to keep in mind is when we're thinking about adding a generator to an energy storage system is a lot of these generators are what are known as standby generators. They're warranted for standby, not necessarily continuous or non-emergency use. We do offer a non-emergency generator where it's warranted for off-grid use. It's warranted for non-standby applications, which is not what our other Power Protect line does, and they're really also not from a lot of our competitors. So again, the idea is that a lot of the generators are meant to be only started when the grid is out in a grid accessible location, where we do have non-emergency air-cooled generators warranted for off-grid and warranted for these demand response programs as well. Warranty, you can see it on the screen. I don't want to go too far into this. I want to get into the meat. But again, a lot of people warranty their products, but do they warranty the labor, the mileage, that truck, you know, the van or the truck that you got to roll? That's fuel, that's tires, that's insurance, that's the guy's hours on the truck. We are able to offer best-in-class warranty. So as we're talking about integrating generators with the energy storage systems, there may be an opportunity to still use transfer switches. Do you need to remove the transfer switch? Can you leave the transfer switch? There's definitely some different schematics that we're going to take a look at here in a few slides. Keep in mind, we do have standard transfer switches. These are usually whole home, and there's service-rated disconnects in there, and they're controlled by the generator. What I mean by that is that the generator is going to send the signal to transfer to this switch. We have Symphony 2 transfer switches that have a little bit more advanced kind of feature. They work in conjunction with the generator. So if the generator sees that grid has gone down, they're going to start up. This transfer switch specifically is going to look for the presence of generator, look for the presence of grid, and then only then, once it sees the proof in the grid and the auto mains failure that the grid has gone down, will it transfer. So again, there's signal transfer, which is the generator, which is monitoring utility and voltage, and then it sends the signal to transfer. That was the standard one. Whereas auto main failure, which is what both the generator and automatic transfer switch are both monitoring utility and then act accordingly. Two-wire start, this is going to be a topic here, is that, so it's neither of those. It's that the inverter itself detects that the batteries are starting to get low and will send a signal to the generator to get it to start up. One thing to keep in mind is load management is definitely a big topic coming up, and this isn't the right talk for that. Go to poweracademy.com or Briggs & Stratton /Power Academy to take a look at some of our power management trainings, but it's out there to kind of drop off some of these larger loads. Nathan, any questions before I continue? Not hearing any? Let's keep on going. So as I mentioned at the top of the hour here, is that off-grid generators have historically always played a major part in off-grid systems, but now we see an opportunity really to have generators play a part in on-grid systems. It used to historically be that you would have a Magna sign inverter, maybe a midnight solar charge controller, some simplified batteries, and somebody else's generator, right? So now we can all have one company with one inverter, one tech support call, and integrate that everybody into one kind of umbrella. So that's really powerful for us. So why are we going to combine batteries and energy storage systems? Is one, it gives you more resilience. Keep in mind is that a lot of people, and maybe put it into the chat if anybody's doing this, is installing just batteries and no solar, right? So if you install just batteries and no way to recharge them, they're only going to last as long as they have juice in them. So what you can do is come into a house, a system, install a battery energy storage system, no solar, and use a generator to then charge up the batteries. And the inverter, the equipment in that battery energy storage system, is going to know when the batteries get low, start up a generator, charge them up at a relatively quick rate, shut that generator down, saving fuel, saving runtime on the generator. So keep in mind is sometimes what we want to do is run the generator as least as possible, especially in an emergency. There may be, I don't see a propane truck making it down that road. So if you are somebody on propane, you do have a finite amount. Maybe you do have a 1,000-gallon tank out there. But again, by combining these things, we're able to save fuel and offer better resilience for our homeowners. As I mentioned before, really generators, when they're in these standby generators, historically run at very little load. And we have histograms, like I said, it's a reading in the controller on the generator, which tells you what load the generator is being operated at how many hours. And what we want to do is, instead of just basically idling the generator, we want to kick that up, get it up to 70%, which is a real most fuel efficient load on the generator, and then shut the generator off and coast on our batteries. When the generator does start up, it's going to be able to help support the loads and charge the batteries at the same time. It's going to extend the life of the generator by not having to put as many run hours. And then again, when the batteries are full, it can shut the generator off, eliminating refueling, maintenance, fuse, and the noise that comes with it. So how do we combine them? What we do is we use two-wire signal to start. A lot of these systems, and I've also seen a lot of times in our inverter especially, the automatic generator module is built into the hybrid inverter. Some of, I'm thinking of, I think Magnums and Outback, they have outside kind of components that you would add to have the automatic generator start a device. And what that does is it's talking to the inverter, which is monitoring the level of the batteries. And then when the generator or inverter sees that the batteries are getting low, it will send a two-wire signal to start. It's either normally closed or normally open contactor that's going to then start up the generator. And what you can do is, usually trigger that start voltage before you get to the low battery cutout voltage, right? So maybe the low battery cutout voltage is at 48 volts. Well, let's set the signal to start. Let's set the inverter to send the signal to start at maybe 50 volts, so that we're not getting too low before we start up the generator and charge up the batteries. One thing to keep in mind with a lot of these lithium-ion batteries that don't have communication capabilities is that it's hard for a piece of equipment like an inverter or a charge controller to determine the state of charge of a lithium-ion battery based solely on the voltage.
Especially when it's under load, right, David?
Yeah, and Nathan, why don't you chime in on that and help us understand that concept a little bit, please?
Well, sure. I'll comment on that. One of the things about lead acid batteries is historically it was very easy to tell what your battery state of charge was based on the voltage, because the voltage of a lead acid battery through the discharge cycle varies by multiple volts, right? It drops fairly significantly. While we are discharging a lithium battery, especially lithium ferrophosphate, which is what we use, LFP, the battery has a very stable voltage from that 10% state of discharge down to that 90% state of discharge. And because of the flatness of that curve, there's very little drop in voltage. And when we're under load, the load voltage drop can be comparable to the state of charge voltage drop. And so it becomes difficult, especially if you don't know how much load is there. So for these reasons, we recommend using our communicating batteries that have, with the battery management system, excellent monitors to tell you the state of charge of your batteries. I did want to ask a question for you as well. Earlier, you asked if there are any good questions you should be answering, and I was busy typing away, so I had muted myself. There have been lots of great questions, and want to encourage more to come in. One question that I didn't know the answer to, an anonymous attendee writes, can you work with an eFlex load management system? It's the most cost-effective residential and small business load manager in the market. Are you aware of the eFlex load management panel, Daniel? I don't know of it.
No, I'm not. But I do know that a lot of these load management companies like Span, like Lumen, like I'm sure eFlex, are usually inverter and battery agnostic. So you might have a second app that you have to use, but incorporating third-party load management, I think, is a great idea. And I would check with them to see who they work with.
Thank you, Daniel.
Yeah. And so back to Nathan's point, if we don't know if the batteries are full or empty, and maybe the inverter thinks that the batteries are empty and they're not, and we start up a generator, we're going to be running a generator unnecessarily, or maybe doing short cycles on that generator. So offering communicating batteries is going to be really important, and makes it work where you're optimizing that runtime to start the generator only truly when it needs to start. Keep in mind, you don't want to undersize or oversize the generator. It is possible to get into some of the settings that if, say, you come out to an existing generator and you add energy storage, you may be able to get into the settings of the inverter and adjust those charge parameters so you're not going to overload the generator. Necessarily, you don't want to have too big of a generator, right? And if you got this huge 26K generator, but the inverter can maybe only handle 40 amps, or can only handle 6K, right? You have this large generator. So that's maybe an opportunity to integrate whole home transfer switches and integrate some other pieces where when the generator does start, we can run some luxury loads while charging the generator and charging the batteries, sorry, and helping to support some loads. Email us, training@simplifiedpower.com, and I'll connect you up with some of our sales application engineers who can really kind of fine-tune the design systems that you're looking at. One thing is that I've kind of heard an argument why not to incorporate generators and energy storage systems is that you're kind of cold starting the generator, and you might be starting it and stopping it and starting it and stopping it more often than you might otherwise do if you're just, say, running the generator for 4 days during an outage, or 8 hours during the outage. And I want to kind of step back on that a little bit, is that Vanguard engine that I mentioned earlier and showed you a picture of, that Vanguard engine is used in more than just generators. It's used in lawn equipment, commercial lawn equipment, pressure washes, light towers. So it's been engineered and designed to have a repeated cold starts. We use the oil system is designed to be more robust, where it's not really going to affect that life of the generator. Keep in mind that these generators do need to be 240 volts AC to feed into not only our inverter, but a lot of other people's inverters, unless maybe you have like a 110 volt MagnaSign or something like that. And again, we're going to wire the generator into the generator port. The generator must have 2-wire start, must have automatic start and stop. That's a little different than I have seen a little generators where it has a start button, right? It has a battery on board and it can start the generator, but that's different than an automatic starting that can listen to a 2-wire signal to start. So, and a lot of those ones have, they're approved for unattended operation, which a lot of portables are not. I want to make sure that the automatic generator start does not interfere with the manual start or stop of the generator or its exercise. So that's an opportunity. Some inverters you can program the inverter to run the exercise cycle on the generator. Or in our example, we can do the generator itself can still be responsible for its exercise cycles, and the inverter is only going to start the generator when it needs to charge up the batteries. It can either be a normally open or normally closed on that. So here we're looking at our inverter, the 6K inverter. And what I'm showing you here is where to wire in the generator power coming into our inverter. Our 6K inverter has 3 ports: a bidirectional grid port, a load out port to our critical loads, and a gen input. The generator input can either be used for a generator, right? Or it can be used for AC coupling. And we'll have to look about a little bit into that deeper if you want to use both AC coupling and a generator. There might be some interlocking breakers you might have to put in there. But essentially, you're going to land your L1, L2, and neutral right there on the gen input in our inverter. And you're going to land the ground, the equipment ground on that green terminal block. If you were to look into one of our generators, there's the Power Protect 26, the Power Protect 12. Its pins 4 and 5 are the 2-wire signal to start. Keep in mind that you also have to get into our controller, the GC 1031 or 1032 controller, and disable auto mains failure. Why? Because these generators have grid going to them. We feed grid to the generators constantly, right? Why are we sending power to the generator? One is to keep the starting battery charged, and also to run any cold weather accessories that you may have in the generator. So that generator is seeing grid power. And remember I said earlier is that some of the ways we set these up in whole home backups with no energy storage system is that the generator is going to look for grid. If it doesn't see grid, it's going to start up. Now, keep in mind that if you have the backup coming to this thing from it's being backed up from the you got it landed on the critical loads backed up panel, it's always going to see grid. So what we want to do is not disable auto mains failure and use pins 4 and 5 for 2-wire signal to start. Jump a little bit more into wiring diagrams here. This is what we got, right? Here would be grid. There's our breaker for grid right here. Non-backed up loads feeding into our bidirectional grid port. Here's our load out port feeding backed up loads here. And here's our generator. Generator feeding into the gen input. We do have the signal to start, which is this kind of purple line you see here. And built into our 6K inverter, we have 2 MPPT maximum power point trackers. MPPT, and I just doubled up on there, but we can land solar, DC couple solar directly into our hybrid inverter. We got our batteries over here on the right. We got a rapid shutdown module as well, and we're able to kind of move that in. You can use portables. A lot of people have portable generators out there. One thing is that I've always seen is a lot of people, have a power outage. They run out to the hardware store, buy a portable generator, and then run it, get it going, and then they put it back in the garage for 2 years before they have the next outage, or a year. And they forget to drain the oil tank, drain the fuel tank, and drain the carburetor. So a lot of times I see these with dual fuel with propane. They're less expensive, but if you are going to use a portable, they do need to be 240 volt. A lot of them don't have 2-wire signal to start, so you're going to have to manually start them. Keep in mind, and I don't want to get too deep into this, but a lot of these portable generators, in fact, I think all of them, have a bonded frame. So whether the neutral is floating or bonded, look carefully in the instruction manuals of the generator, and maybe consult an electrician if you're not sure on this, on whether or not you need to leave it bonded or not bonded, and how you're going to do that if you're going to be running a portable generator into a whole home kind of backup situation, or even a partial home backup situation. Again, I always encourage people to use propane, so that you're not going to have to put Sta-Bil or sea foam into the gas tank of that generator to keep it from kind of clogging up the generator when you want to use it. Another thing to keep in mind is we're not going to turn off our main grid and then unplug our dryer and then plug our generator into the dryer outlet and backfeed the home. That is not up to code. And one thing that can happen is that if you forget to say turn off the main, you could be that house on the neighborhood backfeeding the grid, and you might electrocute the electrician lineman down the road who's trying to get power back on in the neighborhood. So it's really important that we follow code and use these portable generators. Keep in mind also that these things cause fires. And so we want to put the generator in a situation probably 5 feet away, right? Keep it away from combustibles. Don't poison your family by running carbon monoxide from one of these generators. So keep that in mind. We're going to close out the hour. I know we're kind of coming up on it here with a couple line diagrams. What do we got here? We got grid, non-backed up loads, feeding our bidirectional grid port in the inverter. We have our backed up loads panel up here. We have our generator. This is a Power Protect 12K, which has some of the highest starting kVA in the market. It can start really big loads. We got that down here on the bottom right. with a 2-wire signal to start. We got some disconnects which may or may not be required. And we have our batteries. In this example, we have 3 of our 4.98 48-volt batteries outdoor rated. And we're feeding it into this midnight solar combiner here. One thing to keep in mind when we are wiring our batteries, you always wire them in parallel. And we always want to wire them in such a way that you're not getting voltage drop between the batteries. And what I mean by that is either use bus bars or 4-aught cable up to 4 batteries, or use a combiner where you use conductors of the same gauge and the same length going to a common terminal point or a common bus bar that you can then feed up to the inverter. We got some DC coupled solar there. We have AP Smart Rapid Transmitter, or AP Smart Rapid Transmitter built into the inverter. So all you have to do is go out and get the AP Smart Rapid Shutdown modules and add those to the solar panels. One thing to keep in mind, and I also got to check this out at RE+, is that SolarArc 15K. A lot of people like the SolarArc 15K now is because it has, what, a 200 amp utility rated disconnect so that we can run grid, run through a meter can, run right into a SolarArc 15K. There's no backed up loads panel in this example. Because why? Because everything is backed up on this whole home backup system. What we can do is use potentially one of our Boss 12 cabinets that you see there that has 12 of our 3.8 48-volt amplified batteries that do have closed loop communications that can transmit its accurate state of charge up to this SolarArc. Then based on the state of charge of the batteries, that SolarArc can send a 2-wire signal to start, either start up or shut down this 26K generator. Why I put a 26K generator on this SolarArc 15K? Because that SolarArc 15K can take 100 amps of generator power. We're able to quickly charge up the batteries using the generator and shut the generator down, saving fuel, saving runtime. That's the point of this talk here. The SolarArc does not have an AP Smart Rapid Shutdown transmitter built in. So in this example, I'm showing you a Tigo. I think these are some TS4F rapid shutdown modules. These are for 2 panels each, but you can definitely use Tigo, or you could potentially use AP Smart Systems. In this example, you just have to get the external transmitter for that AP Smart on this. Off-grid. Simplify Power, Briggs Stratton Energy Solutions warranties our equipment for off-grid use. A lot of our competitors do not warranty for off-grid, and we do. So here's an example. What we have is there is no grid. Everything is backed up. We got our whole home right here. We got our generator. We got that same midnight solar combiner. We got the same AP Smart Rapid Shutdown transmitters right there. One thing to keep in mind is when we are going to use a portable generator is using interlocking breakers. So in this example, that portable generator will never be able to charge the batteries. Why? Well, I don't necessarily care that much. Why? Because what I can do is that if, for example, the batteries are starting to get low, it's cloudy, it's nighttime, what I can do is simply get into a panel, use interlocking breakers, basically isolate the energy storage system, the batteries, from any loads, start up my portable generator, and use a portable generator to power the loads until such time that the solar has had a chance to recharge the batteries. So that's a good example of not necessarily using the generator to charge batteries, but still having a generator support an energy storage system by taking over the loads. And there's examples to do this with standby generators as well. You can definitely use interlocking breakers as kind of a more of a robust system that you see here as well. You can parallel up our inverters into this example here using 2 of our Boss 12 cabinets and kind of provide that more of that whole home backup situation as well. Again, thank you everybody for being here. One thing I do want to promote is our Power Academy. If this was a class you like and you want to learn more about the generators, more about the energy storage systems, log into briggsandstratton.com, Power Academy, and go ahead and create an account and start your in-person learning. We can come out, schedule that there, e-learning, Power Academy Live, or live virtual as well. Take a look at our Simplify Power training upcoming calendar. We're going to be talking about AC-DC coupling. We're going to be talking about environmental considerations. We're going to talk about energy sales made simple, right? Let's make these sales simple to the homeowners, to the business owners. And we're going to talk about how we can use packages from Briggs Stratton Energy Solutions to make that sale. If you're an installer that's on this call today, please consider joining our installer program. There's a lot more benefits than what I just showed here on the slide. We'll put you on the maps. We'll promote you in some of our literature and our newsletters, but there is money back opportunities. Get your phone out, scan this QR code, and I look forward to you having you part of our IQ program. Questions, comments, training@simplifiedpower.com. Nathan, any final thoughts or questions from you?
Oh, there were lots and lots of great questions. We had over 30 questions come in.
Great.
One question Diane said is first, she says, this was a great presentation. Thank you. Will you please share your slides? So Daniel, can we get these slides out to everyone?
Yes, we definitely can. And if you want any more in-depth and or want some more one-on-one, email me training@simplifiedpower.com, and I can even run through the slides with you, kind of a one-on-one if you like.
That's wonderful, Daniel, that you're willing to do that. I do want to let everybody know that this presentation is recorded and we will be sharing it on our YouTube channel as well. So if you missed something or maybe got a little distracted or maybe didn't understand something and want to go back and review, you'll be able to see this on our YouTube channel, and everybody that's registered will be getting that recording as well. So we'll get the slides out to you and you'll get a recording as well. Thank you so much for your attendance.
Thank you, everyone. We'll see you next time.